two stars each of one solar mass. Okay, that means here you have given that mass is equal to one solar mass, that is m is equal to 2 into 10 raised to 30 kg, are approaching each other for head-on collision. Okay, मतलब ये दोनों आएंगे for head-on collision. Okay, when they are distance 10 raised to 9 किलोमीटर. ओके, ये डिस्टेंस है 10 raised to 9 kilometer. So you can say h is equal to 10 raised to 9 kilometer. Thereafter speeds are negligible. What is the speed with which they collide? मतलब जब वो कोलाइड होंगे तब उनकी स्पीड क्या होगी? ओके, दैट मीन्स हियर वी कैन से दैट here for example यहाँ पर आ गए. ओके, when they collide, ये हो रहा है collide. That means here you can say that like this. So here we can say that final velocity is equal to v, and here you can say vf is equal to v. ओके, और ये दोनों के सेंटर के बीच का डिस्टेंस हो जाएगा, दोनों के बीच में हो जाएगा 2r. मतलब यहाँ पर ये डिस्टेंस है r और ये डिस्टेंस भी है r. सो यहाँ पर डिस्टेंस हो जाएगा 2r, राइट. सो हियर you can say that the initial distance x is equal to 10 raised to 9 kilometer, that is 10 raised to 12 meter, and radius r is equal to 10 raised to 4 kilometer, that is 10 raised to 7 meter. ओके, नाउ सेम वे यहाँ पर हम यूज करेंगे लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, दैट इज यूजिंग law of conservation of energy, that is initial energy is equal to final energy, that is the initial kinetic energy plus initial potential energy, that is the final kinetic energy plus final potential energy. So initial kinetic energy होगी 0 because speeds are negligible, minus g, दोनों का मास सपोज m कंसिडर करते हैं, दैट इज जी एम स्क्वायर बाय एक्स इज इक्वल टू फाइनल काइनेटिक एनर्जी. ओके, अब इसकी भी काइनेटिक एनर्जी, इसकी काइनेटिक एनर्जी हाफ एम वी स्क्वायर, इसकी भी हाफ एम वी स्क्वायर. ओके, दैट इज हियर फाइनल में काइनेटिक एनर्जी रहेगी, यू कैन से इट इज हाफ एम वी स्क्वायर प्लस हाफ mv square, and here potential energy, that is a minus gm square upon 2r. That is here you can say that minus gm square upon x is equal to half mv square plus half mv square, that is the mv square minus gm square upon 2r. ओके, नाउ व्हाट हैपन, m गेट कैंसल, मतलब यहाँ पर m एक m एक m. Therefore you can say that v square is equal to gm upon 2r minus gm upon x. Okay, that is gm is a common 1 upon 2r minus 1 upon x. Okay, so here we can say that v square is equal to value of v 6.67 into 10 raised to minus 11 m, that is 2 into 10 raised to 30, 1 upon 2 into 10 raised to 7 minus 1 upon 10 raised to 12. So here you can say that v square is equal to 6.67 into 10 raised to 12. So v is equal to 2.6 into 10 raised to 6 meter per second. Right? So once again the same concept that we use here. Next, 8.21. Two heavy spheres, each of mass 100 kg and the radius, okay, each of the mass m is equal to 100 kg and the radius 0.1 meter, okay, that is r is equal to 0.1 meter, are placed 1 meter apart on horizontal distance. R is equal to 1 meter apart on a horizontal level. What is the gravitational force and the potential at the midpoint of the line joining the center of the sphere? Is the object placed at that point in equilibrium? If so, then equilibrium stable or unstable? Right, friends? So just focus here. That is here. We can say that suppose it is a object, or you can say it is our sphere. Okay. Here we have two such heavy spheres. Okay, so they are placed like this. Right? Here we can say from the center to center. Okay, and midpoint जो हम consider कर रहे हैं, you can say it is your midpoint, right? And here the total distance are, so this distance is r by 2 and this distance is r by 2. Okay, now here gravitational field, suppose here we can say it is a point A, it is a point B, तो यहाँ पर gravitational field होगा EA और यहाँ पर होगा gravitational field that is a EB. Okay, now here gravitational field at midpoint, gravitational field at midpoint, that means you can say E is equal to EA plus EB. Okay, but दोनों है opposite direction में, that is you can say that GM upon R by 2 whole square, ये है EA, that is minus direction में, so it is minus R cap plus GM upon R by 2 whole square plus R cap. So here you can say it is a 0. Okay. So here we can say that effective force is 0. So we can say that effective force at midpoint is 0. Therefore you can say that the body is in equilibrium. Okay. Now gravitational potential at midpoint. Gravitational potential at midpoint, that means you can say V is equal to VA plus VB. Okay, what is the VA? That is minus GM upon R by 2. What is the VB? Minus GM upon R by 2. That is minus 2 GM upon R by 2 minus 4 GM upon R. Now substitute all this value. Minus 4, G is the 6.67 into 10 raised to minus 11. ME, that is the mass is 100 and R is equal to 1. Okay, so here you can say that total V is equal to minus 2.7 into 10 raised to minus 8 joule per kg. Okay, that means if a body is displaced slightly from the one side of the equilibrium position, it will not return back to the initial position of equilibrium. So the body is unstable equilibrium. Okay, so body is in equilibrium, but equilibrium कैसा होगा? You can say it is a unstable equilibrium. क्यों? क्योंकि वो अपनी ओरिजिनल पोजीशन पर वापस नहीं आएगी. क्यों नहीं आएगी? क्योंकि यहाँ पर जो फोर्स है वो फोर्स 0 है, टोटल फोर्स है 0 है, राइट? So that is why.